Hey everyone, so today we are going to be going over Mecanim, and this shouldn't be too long. We're going to go over it very briefly. There's a lot to Mecanim, but Mecanim is a Unities system for character animation. It can be used for all sorts of animation, but in particular we're going to focus on 3D rigged characters, so if you want to make a character for like a third-person game, platform, or whatever, you're going to be using Mecanim. So I wanted to find some free 3D models that you could just download and use. I'm not a modeler, I'm not a rigger, I'm not an animator. I mean, I know how, right? You gotta know how to do a lot of different things to be able to understand them, but I like to leave that up to people better than I. So I looked around, I found this site called CG Trader, and I saw a couple different models that were rigged and animated, ready to go. So I grabbed this one, Human Base Mesh Animated, and this Medieval Woman Warrior, and I dragged them into Unity. So they didn't come when I imported them in, and we talked about importing models in the very, very first lesson. When I imported them in, they generated some materials. One of them didn't actually come with the textures importing in automatically, and so I had to drag in the textures separately onto the materials that were created. So if I click on these guys, these were all FBX files. So FBX files store lots of information with them. Most notably, they can store material and texture linking data as well as animation data. So the medieval character and the base mesh that I imported came in a couple different ways. So when I click on these guys, in the inspector, I'm going to go ahead and just make this stuff pretty big for the time being, okay? When I get to the inspector, okay, I have these three tabs: model, rig, animations. Remember, I've made this model, so I can go ahead, I can drag this guy in, and drag the other one in, and looks like their scales are slightly different. But, you know, we've got some humanoid models that we can work with. If I go ahead and hit play, by default these guys probably won't be doing anything. Looks like one of them... Nope, they don't do anything. Anyway, so if I click on their import settings, right, I get model, rig, animations, models where I can mess with the scale factor, and we're actually going to go ahead, we're going to leave this model tab pretty much alone for the day. We might fiddle with this scale factor, but other than that, we're going to leave it be. So these guys are generally pretty different, and I want to show you something with medieval character, but we're probably going to be using the base mesh to go through this, just to save some time. But you could, in theory, do it with both things. So when you import a mesh, you get a couple different options inside rig and animations. Okay, the best way to make use of Mecanim. Alright, we have a bunch of different animation types. If you are animating something organic, especially if you're animating something that's a humanoid, you're going to want to swap this to humanoid. Okay? And then you are going to define an avatar. So the standard human rig, so to speak, is, well, if I click this configure button, you can actually see it. I'm going to make a main scene here, right? This is going to open up a new editor, and I actually get to... This opens up the model imported into a brand new thing. So in order for all this to work, the model you're importing, I'm assuming, is rigged and has some animations on it already. We're not going to cover everything about Mecanim. There's so much to cover. We're just going to show how we slice it up and use it inside Unity. So if your rig follows somewhat a normal body layout, it's going to actually figure these things out. So you can see it's auto-assigned different joints to parts of the body. So I can focus on the head, and you know, a lot of these things are optional. So if I go ahead and start moving these around, right, you see I'm manipulating it like a rig. And I can do the same thing with my medieval character. Done. Right. I say humanoid, apply these settings. Alright, it looks like this guy might actually have a problem with the built-in settings, but I think we'll probably be okay. And this is because this has some extra things in it that we don't really want. But if I go ahead, I can, again, move these things around. So that's the spine, right? These points drive the rig, okay? And it's just like a rig in any 3D program. So it's just all of the rigging spots, all the bones, are represented by invisible game objects inside the character's hierarchy. So, let me click done. And again, we're probably not going to be using the medieval character because it's going to be a little bit more complicated, which we'll see in a second. But if this becomes a problem, we'll swap a little sooner. Okay, so after I've swapped to humanoid, okay, and since we're talking about human rigs today, we're just going to assume that you've done this. Again, if you want to, kind of any object can use generic animations, but humanoid gives us a couple options, especially if you want to start using more advanced features like inverse kinematics, and there's all sorts of great stuff that you can do because of this. So that's mostly it for the rig. A lot of people will make separate FBX exports for individual animations. And you see this avatar definition and how it says create from this model. You can import just the animation data and use a different rig. And this actually allows us to use animations from one FBX in a different FBX. And maybe we'll try and do that where we could, in theory, since we are all mapping rigs onto specific points, we could actually take animations from the medieval character and apply them to this guy. So the third tab, okay, animations, if I click over here, we are going to get a bunch of different stuff, okay? Like I said, we're kind of going to ignore some of these warnings for now, but basically, when the medieval character, you can see I have about 700 frames of animation data inside this file. Alright, that's what this means. This range, this is how many frames of animation data were in the FBX. So if basically from the point where the first keyframe was to the last keyframe, it's going to import this stuff. And if I just go ahead and hit play, you're going to actually see those animations play sequentially. And inside this little preview view, I can move my guy around and all sorts of stuff. So you see stuff like this. This is probably what I did with the rig. In fact, let's go back and let's say this is generic for the time being. So we can watch this how it's supposed to be. Okay, and now if I hit play, see I can scrub forward and backwards, and there you go. So you can see it's playing all the animations back to back to back. This is not a good way to organize files. You know, if you're some CG programs will let you kind of organize animations, and then the FBX importer will know to auto-slice those up. Otherwise, you are going to need to talk to your animators and get a list of what keyframes animation was happening. Now, if these were separated into separate FBX files, with each FBX file just containing one animation, this would know what the frames are automatically. So without that, we have to slice up these animations ourselves. In contrast, let's look at the base animation character. Okay, this is just using it just as these came. So this asset creator did something nice for us. They made built-in animation clips. Okay, so it has this idle. Okay, and it's not the greatest looking animation, but it it's fine. I took a look at the run earlier, and this is also not the greatest run cycle in the world, but if we just want to talk about how we use these animations, it's okay. Okay, and similarly they have a walk. So, in general, the way animations cooperate with most game controllers, right, is the collider is the controller, and then the animations are sort of just incidental and graphical. So, unless you're doing some sort of inverse kinematics and you care about where specific joints and hands are, you mostly are just going to be functionally you're just sliding the character along, right, and letting the animations play. So, let me hop back over to the medieval character. Okay. So, sorry, back to this guy real quick before I hop there. I mentioned that this guy set it up in such a way that I could swap between these different animations, and this is really useful. This means these animation clips are already built, and I can plug into Mecanim, which we'll talk about here in a second. Now, on the medieval character, I need to slice them up myself. So, somewhere in here, okay, is an idle loop, okay? Where is it? Looks like it's somewhere in here. We could say looks like it starts around a couple different frames, and this is what I want to carve out of this, right? So at some point this becomes jump, and all sorts of things, right? So I need to specify which frames are which animation, alright? And this is another reason why it'd be helpful to have individual FBXs, or have it organized like this, so that Unity automatically knows which frames of animation data are animation clips. Otherwise, it's really hard to make small changes. And you will have to do this process that we're going to do here multiple times. So I want to rename Take 1 to Idle. And you'll see I have a list of animation clips that I can add and subtract from right here. So for Idle, okay, I'm going to stop it frame 33, looks like about where that idle starts, okay? And that could be off a frame or two. And it looks like this is her looking left and right is just still part of this idle. And we'll let that come back. Oh, alright. Alright, and it looks like it stops around frame 305. So you can see that I have all this data here. So now if I hit play, let's see what happens. Right, it'll automatically loop in the editor, but we are going to have to set some couple optional things here. Alright, that didn't loop visually, but if I toggle this loop option, loop time and then loop pose, Unity will try its best to interpolate the values to make it look seamless. So you saw that? It looks like there was almost no hitch as opposed to what we had before. So I'll just skip ahead to the end again and we can watch that. Now if I toggle this off and skip ahead to the end, you can see there's that definite jump. Whereas this does its best to smooth it, but you can still kind of tell when it loops. Particularly in the feet, you see shuffle back. So I could go ahead and hit apply here, right? I have my idle. Alright, cool. And I'll leave that like that. So I want to make a new clip. I want to find the walk cycle, or run, or whatever. This probably just has one, but I'm going to call it walk. Okay, and I'm going to scrub through again. And I know it was after frame 305 is really when we saw something start. So I'll set it to 306. Alright. And it looks like if I scrub, it goes all the way to about 369 and loops. So I'll set that to that. Alright, and if I hit play, we can watch her run. It still doesn't quite look the greatest. And I can keep fiddling with these values until it loops somewhat how I want. And you can see, though, things start to get a little janky. Because it's trying to make it look like it's looping when it's really just not quite what we want. So this process is really frustrating, right? So you really want exact keyframe data. And now the source from this model came in 3ds Max, which unfortunately I do not have installed currently. I could open it up and look at it. Instead of doing that, this is why I brought in this other model. But let's say I wanted to keep going, right? What if I wanted to jump, okay? Now the jump is an animation that we're not going to loop, and that looks like that. Starts around 540-ish, and then goes to like 580. Alright, so if I play this... Alright, that looks pretty reasonable, right? Now the character's just jumping over and over again. And I will rename this to jump. And idle, walk, and jump is, I can do a lot with just those three things. Alright, so let's see, how does this guy look? Maybe we can use this model. Well, still not the best. See, this is frustrating. So, we'll leave this be. I'll hit apply. Maybe we can fiddle with it a bit later in the video, but let's go over to this guy, okay? So, because it's a humanoid model, Unity actually provides us some tools to show that things are looping properly. So, before, okay, I didn't have this green light, and this can be green, yellow, or red, based off of how well the thing's looping. And always remember to, if you want the pose to loop, be sure to set these, okay? Otherwise, we will run into problems with the animator later. You definitely want to check loop time and loop pose. Okay, so I could actually move this animation around, and look at that. Now the loop, if it doesn't think it'll make a seamless loop, it'll tell you, right? And it looks like this animation was set up in a way where we could almost put this frame anywhere. If I put it to the yellow and hit play, we're going to see a bit of a weird hop, right? Doesn't quite make sense. So now if I leave it like that, loop's pretty good. Same with its other. Yep. So this is all stuff that you can fiddle with, and we're going to talk about these root transforms in a little bit, but we're probably not going to even touch on curves and events. We're just going to talk about how we set up our Mecanim state machine. Okay. So I'm going to make these guys a little bit bigger. I'm going to go ahead and delete this one out of the scene for now. And we're going to focus on this guy here, right? So again, if I hit play, nothing is happening. And that is because there's no animation controller. Alright, and yeah, I'm going to rotate this guy 180 degrees so that he's facing us. And what I need to do is I need to add an animation controller. So if I go up to Window, there's a couple things I want to open. There's Animation, alright, and this we are not going to concern with too much, but I'm going to go ahead and dock it in here, and there's Animator. Alright, so Animation lets us animate things right inside Unity, and Animator lets us set up our Mecanim state machine. So again, Mecanim is the vehicle to handle animation inside Unity. And in order to get this to work, I need to create an animation controller asset. So I'm going to go Folder, Animation, and then inside here I'm going to make a subfolder called Controllers. And I'm going to make an animator controller, and we will call this guy Character Animation Controller. Alright, and now you see, now that I have this clicked on, right, I get this stuff popping up inside this animator window. And to move around in this guy, you have to Alt left click to pan. It's a little annoying, but otherwise you can scroll up and down. It's a little unwieldy. But what you see is we have a couple different nodes here. And this is a node-based coding editor, basically. So if you've ever seen Blueprints or Playmaker, Blueprints being what's in the Unreal Engine, Playmaker being a popular asset store add-on, it's sort of the same idea. We are essentially coding a state machine, and we are going to create a couple different animation states, and when we're in those states, we're going to play different animations. So, our most basic states that we're going to have are let's take a look at our character, right? We are going to want to focus on the clips that we already have. We have walk, we have idle, run, and walk. So we're going to want to make those states. Alright, and very basically, if I just right click anywhere, I can hit create state, okay, and we will call our default state idle. The first state you make is going to be the default. You see, that's why it's orange, and every state I make after, and I'm going to want 2 more, are gray. And I'm going to want states called run, and let me close out of my emails so you don't see that, and walk. Okay, now we might wind up condensing these states with something called a blend tree, but that's kind of a more advanced topic, and I don't think we're going to cover that in this video. So let's arrange these things kind of in a way that makes sense, so that we know the entry point is where the controller starts. This is just really kind of something visual, but it's going to transition. At entry, it's basically going to be in its default pose, which is what it looks like now. Okay, and then it's going to transition into the default state, or some sort of intro state. So this would be really useful to understand if you were spawning an object, but otherwise you can mostly leave it be. So what we need to do after we have this idle or this entry point, okay, we need to set up the flow of our animation controller. And what we want to do is we want to say, okay, by default we're going to be idle, but how do we ever transition from idle to walk or to run? Okay, so if we had a character controller, there are a couple different parameters we would set in code, and we need to set up those here and then hook into them in our scripting. So I am going to make a couple transitions, right? I want to be able to transition from idle to run, and then I want to transition from run to idle. And I make these transitions by right-clicking a state and clicking Make Transition. Okay, so I also want to be able to transition from idle to walk, and vice versa. I want to transition from walk to idle. I also want to transition from run to walk, and from walk to run. Okay, so now that I have this set up, there are a bunch of different things I can do, but I'm going to leave these transitions at their default values for the time being, and what I want to do now is I want to link in the motions in these different states. So when I click on these states, you see that I get stuff in my inspector. Notably, I get this motion field. Alright, so I am making a controller for this guy. Okay, and I want to drag in the animation clips I have. So I have run loop. I'll drag that in there. And it looks like naming got a little weird here, so let's see what's going on. Looks like this is walk. 0 to 39. Not sure what's different. Strange. 0 to Oh, interesting. Okay, so I was, I could actually swap clips to different sources. Oh, that's interesting. Anyway, like I said before, you learn something new about Unity every day. I wouldn't worry about that. That was just because I set something that I wasn't supposed to when I imported it. So, okay, so now if I go back over here, I have the run loop, idle, I want to assign idle, and walk, I want to assign walk. And let me double check, I want to make sure that those were actually set to looping. So run loop, set to loop, idle is not set to loop, and walk is also not set to loop. So I'm going to go ahead and apply those changes. Otherwise, weird things are going to happen. So right now I'm saying when I go into idle, and automatically these transitions say when this state finishes, we're going into this other state. So that's if you have one state. So not quite sure what's going to happen right now when I link this up, but now that I've made my controller, I need to drag it into the object I have in the scene. So you see this spot for controller? I can drag and drop my character animation controller in there. Alright, now if I hit play, there you go. You can see the guy's going through the motions. Looks like he's going from idle to run. So when it's playing, I can actually toggle over to my animator, and you can see the blue bar is filling up. You can see it even flash along the transition. And this is just saying that when it's done going through root, head over to run. Sorry, when it's done going from idle, go over to run. Not root, I meant default, basic, whatever. And that's because that's because of how these transitions are working, okay? Transitions happen when certain conditions are met, okay? So in this animator, I want to set up a couple conditions. If I have a character, right? What's a common value that characters will have? I could set these as booleans and then just say, oh, if run is true, transition to the run state, or if walk is true, transition to the walk state. But then I have to keep track of a bunch of different variables, and that can actually get kind of sloppy. Instead, what are these states? Run and walk are similar motions or similar animations, but for different speeds. So I can actually say, I can make a, whoop, nope, wrong button, sorry. Instead of layers, we're not going to talk about animation layers today, but those are really useful features. I'm going to click over to parameters, and I want to make a new parameter. You see, I can have a float, I can have integers, I can have bools, and I can have triggers. These are the 4 different kinds of parameters, and then the conditions I'm going to make are going to check the values of these parameters, and my scripts are going to change these parameters while the game is running. So I'm going to make a float called speed, okay? And so when speed is 0, right, when I'm not moving, I want to go to the idle. So both of these conditions, and I can multi-edit them, I want to add a condition for speed, okay? And I can click this, and if I had more than one parameter, you'd see it there, and I say greater, less. I'm going to say less than, or, you know, let's say greater than, like, a very small value. There is no equal when it comes to the float, so you tend to want to do a small value. Alright, and then now, you see this preview? These transitions, okay, let you watch the motions and see what happens when the transition triggers. So if speed was less than 0.1, right, it would transition from walk to idle. And it would look like that if it was playing at, I think 24 frames a second. I can actually toggle the speed of playback here. Alright. You can see that's not the greatest transition, so I could drag that out a little bit. I could say, you know what, start transitioning, make the transition a little bit longer. And you can start making it a little bit smoother that way. And what it's doing is it's actually blending between the two motions here really smartly. It's what we talked about tweening, right? When it's interpolating between values, that's what it's doing. It's saying, at this point in time, we want to find some average, we want to remap the value from 1 to here, or we want to average it. Okay, and that's how it makes the transition. So that was the transition from walk to idle. And hopefully the one, I guess you can't multi-edit them at once. So I need to set up these transitions for each one. So for run to idle, it's the same thing. I want to make speed, when speed is less than 0.1. Alright, see, that's also a really fast one. And I may want him to stop pretty quickly, but I don't want him to slow down. Or maybe I do. So this is all stuff that your animators should need to tweak. And because of the necessity to tweak these visuals and transitions, this is why it's so integral that everyone in your production is able to go into the game engine and tweak things. Right, if you ask the programmer to set up these transitions, for example, they're gonna make something like I make, which to me this looks like this could be okay, but this could be the wrong feel for the character. So I will leave that like this, right? So I have the transition from run to idle and from walk to idle. Now I need the transition from run to walk or walk to run. Okay, and or sorry, let's start from idle to run and idle to walk. So we'll say the run speed, you're running when your speed is greater than 0.9. So we'll represent speed as a normalized value from our code. So our speed can be from 0 to a billion, but we're going to normalize it and then pass that in. And that means we're just going to say from 0 to 1. We're going to give it a percentage. When we're at 90% speed or greater, we are going to be running. Okay? So, and walking will be if our speed is greater than 0.1. Now, this is slightly confusing, right? This won't necessarily look the best, and this is when you're going to start wanting to use things like blend trees, but we're just setting up basic transitions here. A blend tree would know to go between walk and run based off of the speed, as opposed to idle would just know to... These transitions are transitioning between different states, so we'll probably look at that here in a second, but we want to get into the code here pretty quick. So we're saying if when speed is greater than 0.1, we're going to transition from idle to walk. And then walk, we want to say when speed is greater than 0.9, transition to run. Okay? And we have the same condition from going from idle to run. So now we want to check that all our conditions have been set. Run to walk, okay? This is going to be different now. When speed is less than 0.9, we'll go there. So chances are we will very rarely use these transitions because we are going to have our speed up and slow down rather than move instantaneously. But now if I go back into game, you should see him stay in the idle state. Right. Which is good. So this is what we expect. Okay, so we'll go into the scene view so that I can zoom in on this guy a little bit. But you see, it's just looping the animation. Okay, and so now let's say I want to transition to walk. I can actually change this parameter when I'm setting it up. So I'll change that to 0.1. And oh, that's right. Our thing says greater than 0.1, so I guess I could change that to 0.11. You see now when it gets to idle, it'll transition to walk. So why is this going back there? Oh, it's saying if speed is greater than 0.1, right? That was supposed to be less than. So I'll change that to less. Right, so when you're testing your animation control, you kind of want to do it through these steps manually so that you can really make sure that it's working right. So we'll say 0.11 again. And now I'm walking. Now let's say I set it to 0.91. Now I'm running. We'll set it to 0.8. We're walking again. And we'll set it to 0. And we're idle. So, something you may have noticed is while I was changing these, okay, it waited until the end of that animation loop. And this is something that you can parameterize. Okay? So, if I click on these transitions again, this exit time toggle means we're only going to do this at the end of our animation. Now, if we toggle that off, we should actually see, and we're probably going to want to toggle this off for everything right now. Is that? Nope, still can't multi-edit. Ah, toggle these off. Okay. Now, sorry, exit time probably wasn't it. Man, sometimes. Okay. Well, there we go. Now it was going instantly. So, exit time is saying really finish the animation, but more specifically, it's it has some of these settings, and you can tweak these. If you have exit time, right, it's going to wait that long to transition. Instead, you just want it to transition kind of instantaneously. Okay, so let's go ahead and hook this up in the code. There are going to be some visual weird things happening, but let's go to the next step. So I need to make I want to make a controller for this guy. All right, so I will make a C# script called character controller. Attach it to this guy, and now Unity looks for scripts called character controller. It's kind of a special name, so you might want to avoid calling stuff character controller. There's a type in standard assets for character controller, but for this purpose, it'll be okay. Let Visual Studio load. It's gonna take forever. Close some windows in the meantime. Okay, so in our character controller script, we want a couple things. Okay, we need to get a reference to our animator, and we could say public animator, anim. All right, and then in start, I'm gonna just check if this is null. Just say get components animator. Okay, I don't like linking things through the inspector after a while. It just get lazy. But now I could link it through if I wanted to, but I'll just leave it blank. Right, so now if I hit play, see, look at that. Okay. So, you know what I'm going to do? I'm going to reposition our camera so that we have a kind of bird's eye view of the character. I'll make that back there. Zoom this in. Make it look something like a third-person controller. Kind of over the shoulder. Alright. Great. I can click on that. You can see the animations are happening. And, sorry, I meant to check when I was here. You can see that get component call got me the animator controller at runtime there. See, now it's none. Anyway, so now in update, okay, I could move the controller. And this is something I probably will do here in a second, but for now, all I want to do is control the animations. Alright, so I'm going to say if W is held, let's run. If Shift and W is held, let's walk. Okay? Otherwise, idle. And all I'm going to do is make a float speed in every frame, and I will say 0f. Then I'm going to say if input.get key down, keycode.w. Now, when we talked about input, you don't necessarily want to use get key down, but just for this simple prototype, that's what I'm going to do. And then if the key code is w, I'm going to say speed is 0.11f, right? Greater than 0.1. That's the stuff we set in the animator. Then also, if input.get keycode.shift, left shift, speed equals 0.91f. And I'm going to change this to get key. Alright, and now I need to set the parameter of my animator called speed. So if I go anim.set, okay, you can see I can see set bool, float, a bunch of different things, and what I want to do is I want to set a float. Alright, I could give it an ID, a string, or a bunch of different things. Instead, so let's see what that is. If I want to give it an ID, it would be 0. It's the 0th parameter in my animator. I could give it a string, I could give it speed, and then I want to give it a value, which is my speed. Alright. Now if I go back here, hit play, okay. Now if I hit W, you see I'm walking. Alright, now I start holding down shift and I'm running. W, shift and W. So, you see this character doing this thing where he's sort of going around? This is something called root motion. And it's a little bizarre. So what I'm going to do is I'm going to actually make my camera a child of my mesh so that we can see this happening. Well, we're really not going to see it happening because now we're apparent. We get the rotation. Since there's no frame of reference, it looks like nothing's happening. But this guy going around like this is a matter of the fact that these animations are actually manipulating the position and rotation of the object. And that makes a lot of sense, right? That's totally what's happening. If I look at the animation happening real time, it's actually the animations of movement and rotation that you make to do whatever are manipulating things. And root motion means if you animated this root node, okay, the root of the mesh per se, it's going to translate in world space, or local space rather, the game object. And I can turn this on and off. You see if I toggle apply root motion, it doesn't actually do it anymore. So now, if I hit W and shift, the guy's not going to like spin around. And that's because root motion is saying let's manipulate ourselves. Now there's a couple ways we can catch this, alright? We can toggle it off here, but sometimes you want root motion. If you're making a game like, let's say, Dark Souls, where your animations actually drive gameplay, your animations drive combat, you want those animations to actually translate your character in world space. So this is when things like whether we use the legacy, generic, or humanoid animation really start to matter and become really powerful. So if I go back and click on this guy, I can click on these clips, okay? And I can scroll down, and you can see this root transform, alright? I can set a bunch of different things, alright? And I can bake it into the pose, do a bunch of different things. I could actually set... man, this would be strange, but I could do this. I could set an offset, and you can kind of see what's happening, right? If I hit apply, I would imagine that my character over here is going to fly up now when I hit play. What pose was this? Run. So now if I hit shift and W, right? There he goes. He goes crazy. And that's because I've baked it into the pose. So if I bake the root motion into the pose, I can toggle this off. Because when it's baked into the pose, imagine it's basically part of the animation at that point. Okay? Let's make sure I turned that off. I think I did. Oop. Oop. Okay. Oh, there it is. There's the walk loop. My bad. So I don't want to bake it into a pose. Now I want to hit W. Oh, I'm still going. Walk. Oh, well, I'll set that to 0. Did I... Turn that back on? Oh, okay. Oh, that's right. So if I have that stuff in the settings, what would be happening is that the skeleton is moving rather than the root. So then that lets me do weird visual things. So now with this input, I'm transitioning between these different animation states. Okay, so if I want to instead make this guy move around, alright, so let's go ahead and do that. We'll say, I'm gonna make a plane. Usual thing, set it up 0, 0, we'll set -1, 0. Alright, got a pivot point, and we want the guy to transition based off of our speed yet again, and let's see, we will say we want to make public floats walk speed and run speed. Alright, and now here I'm going to say walk speed, run speed. And then what I want to do here is I want to move my character forward based off of that speed. So I'll say vector 3 position equals transform dot position. Yep. And then position, we want to move them forward, equals transform dot forward times speed. Alright, we want to make it time safe, so I'm going to say times time dot delta time. And then we want to normalize it. We're going to assume our run speed is our max speed, so I'm just going to say speed divided by run speed. Alright, and this just means if we're speed divided by max will equal a value between 0 and 1. It would be normalized value. And walk speed we want to actually make sure is like 1/10. We want it to be kind of just above the run speed. So we could do that if we said, if we went over here now and we said the run speed was 100 and the walk speed was 11, then when this was normalized it would be above 0.1. So, okay, so if I play, I hold W. Oh, forgot to assign the position. This dot transform dot position equals position. Now if I play, move forward, my guy is fighting. Oop, what did I do? Looks like my animation is actually resetting it back to 0. Okay, so this was all according to plan, actually. So what we've just seen is why root motion is really tricky. And it's why we almost never, and I'm going to say 99% of the time, we never want to have our animated mesh be the root of our character controller. Alright? And that's because our animations are actually overwriting the values. You can see this weird tweaky motion I've got going on. That's really annoying. We don't want that. So instead, and this problem is why I went ahead and parameterized this early. So we're going to have to come back here. I'm going to create an empty child, and we will call this character. Alright, and now the character's mesh is a child of here. I made it an empty child so that I wouldn't have to reset the positions. You can see this like this, alright? And I'm going to move this guy. I'm going to copy it. I'm going to remove it from here. Right-click, paste the component as new. And now I'm going to drag the animator from here to here. And now, when I walk, I also did the math wrong. That would have still been broken. There we go. Now I'm walking. And I'm walking really fast. So, probably don't want the speeds to be that high. So now if I set these to like 1 and 10 though, right? I'm almost always going to be between walking and running. So you can see walk is really bizarre now. When I just hold W, but now if I hit shift I'm going to go into run. So what I could do is I could set walk to 1.1. And this, I just want to make sure that my walk speed is high enough so that when it translates into my animator component it actually goes. So 5. That seems reasonable. Alright. So now let's say I want to make a character controller. We're going to step away from Mecanim for a second. I could make this guy a parent, or make my camera a child of the 3D character controller again, and now I move with it, right? Great. So I'm not using physics or anything to drive this right now. I'm just doing translations. This is not ideal, but it gets the job done. I'm going to go ahead and import some of our standard assets. Import characters. I just don't want to go through all this code, because these are things we can grab, so I'll go ahead and import all of these. And standard assets actually has another another model that you could use to drive your own Animator controller, but I wanted to show you guys what it was like to make one, excuse me, from scratch. So now to make our character controller behave a little bit more like your character controller, where we can use the mouse to look around, we will import a script from here. Okay. Standard assets, characters. Let's see, we should have mouse look. Mouse look, there we go. Okay. So mouse look is going to translate, is going to move our camera. Oh. Unity. Alright. Looks like we might not be able to use mouse look. Is there other one? They had simple mouse look. Oh, there we go. Okay, simple mouse look. The other one was specific for the first-person character controller. Apologies. Okay, so mouse look. If I hit play, you can see now I can move my camera around independent of my character. And this is getting a little bizarre, but it sort of works. But this is only moving the rotations, so I could mix this up even more. I could now make this sort of thing. This is all just playing around with the hierarchy, by the way. I just want to make something really simple. There. Okay, so now I'm always going to move in the direction that my camera's looking. This is going to be really wacky. But it works, I suppose. So this really just illustrates that you would never really make a third-person character controller from scratch, or if you were going to do it a much better way. I don't want to rotate around the x-axis at all, so I will get rid of that guy. And now we're cooking. So, there are so many things we can do with Mecanim and character controllers. Let me go ahead and undo. This setup I had with the main camera and the character like this, I don't want to recommend. I do not recommend it. Let's compare this to Unity's built-in third-person character, okay? We got the third-person controller. I will go ahead and disable our own for the time being. Here we go. We have theirs. Scene is missing full screen camera. Oh, bloop. I'm going to move our camera onto it. Flip this guy. Alright, so you see, this guy is actually moving the object based on the input. That's what you would do. You wouldn't really want to move stuff based around the mouse. That's what you do for a first-person game. Anyway, you can see Unity's made this character controller pretty reasonably, and it uses very much the same things that we did. So if I look at you can see here's where their animator controller is, and go ahead. Alright, you can see that theirs is a little bit more complicated. They have different names for their states, so they are detecting if their character is on the ground, and when they're on the ground, they're playing a blend tree. We talked about blend trees before, but a blend tree is saying play these different animations based off of some value, and it's doing that based off of its distance from the ground and different things. There's a lot of stuff it does. So if you're really interested in Mecanim, please do a deeper dive. It is a huge feature inside Unity, and if you are making a 3D game in particular in Unity, you will use Mecanim at some point, unless your game has no animations, which is unlikely. Even if you're doing a sprite game, you probably are going to hit Mecanim at some point. So, theirs is obviously much more exciting, but I'm going to go ahead and disable theirs again for the time being, and re-enable ours in all of its glory. Okay, what I could do is I could actually grab our stuff and replace their body with it, but we're not going to do that. I'm just going to go ahead and delete this guy. And reload it all here. What I am going to do, though, is I'm going to show you what's awesome about humanoid animation. Okay, by bringing in standard assets, I can swap the states on this guy with different animations. Because I have a humanoid rig, it's going to know how to apply these things. So for motion, here, let me click on this and look at all of the different things I have. See, I have humanoid run, which is one of the ones that those standard assets gave us. And now if I go humanoid, do they have walk? They do. And then idle, humanoid, idle. Alright, these are different animations, but I'm going to apply them to the same mesh. And so, the person who created this asset didn't make these at all. These are the same animations that we're playing on, that we're playing on our other, on the built-in third-person character controller. And you know, let's go ahead and get this guy going, and I'm gonna change this to, let's use the vertical axis. We'll say float input equals input.getAxis vertical. And remember, vertical is the built-in axis for W and S, so I want to be able to move backwards. And I'm just going to multiply this by input. This is still a sloppy character controller. These get keys to set the animation speeds are not really what I want to do. In fact, we can get rid of this, and I can just say set float here. I know my input's a value between 0 and 1, so if I'm not holding anything, I don't want to move at all. I'm just going to say mathf.absolute value of input, so that it's always between 0 and 1. As opposed to negative 1 and 1. So if I let this guy go, great. And now I can move backwards as well. Oh, oops. I'm not even using the speed parameter anymore, so I want to get rid of that. And we don't need both of these speeds anymore. We're just going to use a run speed. And now I'm going to actually transition from 0 all the way up to my run speed, because this is like a joystick controller. So you can see that I briefly walk for a second, and then jump into the run. Likewise, I can go backwards. And this is because of what I have going on here. So again, we can look at the character from here. If I hold down W, you can see it going, and if I let go, it goes back through. You can watch the transitions. So, instead of doing it with these transitions, let's do it with a blend tree, and we'll end on that. I have idle, run, and walk. So I want to compress run and walk into a blend tree. And instead of this, I'm just going to go ahead and delete these guys. I want to create a new state from a blend tree, and we will call this movement tree. And I will make a transition from idle to movement tree, and from movement tree back to idle. I don't actually need this, but in fact I don't need it at all, so I'm just going to delete it. I can do everything in one state just based off of the speed, and I can do that with the blend tree. So idle is going to be a blend tree, and blend tree is going to be based off of a parameter speed. So let me click that again. So when I right click this, I hit create new blend tree in state. Motion stops being an animation clip and becomes a blend tree. And now if I click blend tree, you see I have a bunch of different blend types, 1D, 2D, etc. Ours is one-dimensional because we're doing it off of one parameter speed, but if we did it 2D, we could have multiple parameters here. But again, we're just going to do it speed. So, and then we're going to have 3 different motions, right? 3 different motion fields for idle, walk, and run. We'll probably actually want more. So we'll start with idle. Okay. Then run and walk. Now these guys might have a one for backwards. No. Let's see. Humanoid. Sometimes, so in a third-person game, you might want to have an animation for walking backwards. It doesn't look like there's one built in here, so I will leave it be and just go ahead and delete this. So instead of doing this with transitions in a state machine, I'm going to do this with a blend tree. So I need to delete, click on it, and go that way. And basically, humanoid, idle, run, and crouch, not crouch, walk, are going to transition based off of certain thresholds. And those thresholds are basically going to be those transition points I had before. And these made them evenly distributed. That's what automate thresholds did. And instead, I'm going to say, these are just saying, when humanoid idle is 0, we're going to be in idle, and up until we hit this threshold, we're going to be running, and up until this threshold, we're going to be, we'll be running, and then everything after will be walking. That's a weird order. I don't want that, because I want to be idle, then walk, then run, and my thresholds, I don't want 1/3. I want it to be like what we had before, which was greater than 0.1 and greater than 0.9. So I'm going to set those to like 0.2 and 0.8. We'll make them a little bit more lenient this time. And so now, if I hit play, I can preview the blend tree, and I can move this value around. Excuse me. And this actually, you can see it blend between all the different motions. So now I'm walking, and then I keep transitioning into a run. So this is really cool. It's blending these animations together seamlessly. Absolutely seamlessly. In one state. So with only changing stuff in my animation controller, if I were to go back here, you're going to see the guy speed up and slow down just perfectly. It's the same parameter, it's the same value I'm setting. So, blend trees, very, very useful. You can see there are so many things I can parameterize, and I really am only scratching the surface. I wanted to show you guys how to import your animations and get something basic going, but you're really going to have to do a lot of research to start making these look really good. But just with basic things, you can get it in and working. So if you have any questions, reach out and contact me, and I will help you as I can. Alright, thanks.